All right, so now we're supposed to find all complex zeros, real and imaginary. So this means, excuse me, we're going to get to a part, excuse me, where we're going to end up with some imaginary probably. Okay, so let's start looking for real ones first. So if I look here, no sign changes. So I'm going to say there's 0 positive numbers that are going to be our zeros. Now, if we change signs, that becomes a negative. That's a plus. That will become a negative, and that's a plus. So there's going to be 1, 2, 3, or 1 negative. Okay. So that's going to help us a lot because negatives are really going to be what we're looking for. We're not going to look at zeros. We're only going to look at our negatives. Now we need to look at our P's and our Q's. Well, our Q is 1, so that's fine. And then we have 85. So 85, how is that factored? Well, we're going to have 1 in 85, that's for sure. We can divide that by a 5, and 5 goes in there once. And, well, let's just go ahead and put it up here, and we'll say it's 1. And then we have 35. 5 goes into 35, 7. So 1, 5, 17, and 85 might be our only possibilities. So that means our now we're going to only use negative q's this time. Our negative p over q is going to be equal to a -1, a -5, -17, and a -85. All right, so I don't know what ones could be, so I'm just going to start with a -1 and divide that in there. And so we have a 1. So we have 3, 2, 1, 0. So we have the right numbers. So we have 13, then we have 57, and then we have 85. So that's a 1. That's a -1. That's 12. That's -12. Then we have that's going to be a 5. That's going to be a 4. So that's going to be a -45. Nope, that doesn't work. That's not 0. What about the next one? How about a -5? So we have 1, 13, 57, 85. Bring down our 1. That's a 1. That's a -5. And so then that's going to be 8. That's going to be a -40. That's going to be 17. Well, I knew 17 times 5 is 85, so it's a -85. That's 0. So this is going to be a factor. So x equals -5 is a factor. Now, what do I have left? Well, that's going to be here, x squared, x, and a number. And so I have x squared plus 8x plus 17. Now, can I factor that? I can't break apart 17 anyway to make that 8. So guess what? We get to go back here and say, okay, it's going to be a -8 plus or minus the square root of 8 squared is 64 minus 4 times a, which is 1 times c, which is 17, all over 2 times 1. Okay, so what do we simplify that down to? Let's put it here, -8 plus or minus square root of, well, 4 times 17. Let's go ahead and put that in the calculator to be lazy. That's 68. So 64 minus our 68, guess what? That's a negative square root of 4. So we have a -4 all over 2. Guess what? Here's our imaginary part. That's going to be a -8 plus or minus a square root of 4 is 2, and a square root of a -1 is I all over 2. Now 2 will go into both of those, and so that's going to be a -4 plus or minus I. Okay, and so we're going to have x equals -4 plus I, and x equals a -4 minus I. Those are conjugates, which is what we need. And so then we have our 3 terms. And so that meant we had 1 negative and then 2 imaginary values here. Okay. All right, so that's how we found all the complex zeros here. -5, -4 plus I, and -4 minus I. All right. Now let's test Descartes' rule of signs to determine the number of maximum positive and negative real zeros. Okay, so again, we've been doing that. All we have to do is, go from here to here and then from here to here. So there's going to be 2 or 0 positives. Okay, and then if we plug in the f of negative x, that's going to be a negative, negative, positive, positive, and so there's going to be 1 negative. Okay, now let's go ahead and plug that into our calculator and see what our value is. Now this time I didn't actually plug it in, so we're going to have to type it in. So we'll have x to the 3, remember to arrow down, then minus 2x squared, and then minus 5x, and then plus 6. Now hopefully our graph has enough space. So we've got 1 negative, 2 positive. So that means we're going to have 1 negative and 2 positive. So that's not going to be a 0 there. It's going to be the 2 and 1. And that's all we have to do on this one. Verified with a calculator, and we have our 2 and our 1. All right, so let's go ahead now and find the dimensions of the box. All right, so again, we're doing a box. And so, we have something like that. So we're doing volume, so it's going to volume is going to be length times width times height. And so now let's write down what we have. It says the length is 3 meters more than the width. So length equals the width plus 3. The width is 2 meters more than the height. And so width equals height plus 2. And so does this help us any? Well, I think what I want to do is I want to solve this one for h. So h is equal to w minus 2. And then I can say w is equal to the width. And then I have everything in terms of width. And I think that's going to be the way to go here. And so I'm going to have v is going to be equal to w, our width, times our w plus 3, times our w minus 2. Okay, width, and then length, and then our height. Okay, now we have to square and then multiply and do all that good stuff. So we have w times w is w squared. And then we have plus 3 minus 2, so that's plus w. And then we have minus 6. And that's still times w. And so that's going to give us w cubed and then plus w squared minus 6w. And now we said that's equal to 120. Okay. Now we get to take that 120 over. And so that is going to be our polynomial that we're going to look at. Now, this one doesn't seem to be very nice because 120, I think, are going to have a lot of factors. So 120, of course, is going to have a 1. And then let's just start going down. 2 and 60, 2 and 30, 2 and 15, and 3 and 5. So those are the basic ones. And then we're going to have anything else. So then we can have factors of each of these. So we can have 2 times 2 is, we can have a 4 and the 30. So we have a 4 there. We can have 10. That's going to be one of the factors because we'll have 10 and 12. So we'll have a 12. So we have now we have 1, we have a 2, we have a 3, we have a 4, we have a 5. Well, we have a 2 and 6, so that'll be a 6, and that'll be a 20. Okay. Now, what can be else? Can we have 8? Will 8 go in there? 8 into 120. That'll be 1. That's 8. That's 40. That's 15. So yeah, so 8 will work. Oops. So we'll have an 8 in there as well. We've got our 10 already. We've got our 12. We got our 15. We just got a 20. Let's see. 21, 2, 3, 24. 24 times 5. That's 20. That's 120. Yeah, so 24 will be a factor. 30 is going to be our 3 and our 10. So yeah, 30, 35, 40, no, 60, and then 120. So we have quite a few here. Now, again, because we're working with volume, we know we're only going to work with P over Q that are positive. So that's going to be a plus. So now let's kind of start writing all these down. 1, 2, 3, 4. We had a 5 in there. We had a 6, no 7. We had an 8, no 9, 10, 12, 15. Then there was a 20. And then we had 24 times 5. Then we had our 30. And then we had our, did we have, yeah, we had 40 because it was 4 times, yeah, so we better put a 40 in there. And then there was a 60, and then a 120. Okay, so there's a lot of them. Now, do I want to start at the top end and work down? I don't think so, because remember, our volume is 120. So we're probably better start at the low end, work our way up, and then, because if we have, 120 plus 3, that's already going to be too big. But, if we have a 1 plus 3, that's going to give us a 4, and then a 1 plus 2 is going to be a 3. Now, it can't be a 1. Well, that would give us a 3, and then minus that would give us 1. So let's start with 1 and just work our way through. So we'll have a 1, and then we have a 1, 1, minus 6, minus 120. So I try to think about things that are going to help me save me time. But 1, it could work because it plugs in here, and that would be a possibility. So 1 times 1 is 1. 1 and 2 is 2. That's a 2. That's going to be a minus 4. That's a minus 4. Minus 124. That doesn't work. Okay. Oh, let's try 2 then. 1, 1, minus 6, minus 120. 1, 2, 3, 6, 0, 0. 2 doesn't work. All right, well, 3. Let's see, how about that one? 1, 1, minus 6, minus 120. 1, that's 3, that's 4, that's 12, that's 6, that's 18, that's a no-go too. All right, so what's our next one? 4. Okay, 4. 1, 1, minus 6, minus 120. All right, so 1, that's a 4, that's a 5, that's a 20, that's a 14. That's going to be 4, 5, 56, but it's a no-go no matter what. What about 5? Hopefully we'll get there soon. 1, 1, minus 6, minus 120. 1, so that's a 5, that's a 6, that's a 30. That's going to be 24. That's going to be, we said that was 120. Hey, that's 0. Yay. All right. Now, so that would actually leave us then with an x squared plus 6x plus 24. Okay. But what do we know about our thing here? We have 1 change here, none here. So there's going to be 1 positive 0. And then there's going to be some others. So what do we need? We need a positive 0. We just found a positive 0. So that has to be the one we're going to need. And so that gives us then length is equal to, and this gave us W. So 5 plus 3 is going to be 8, and we have meters this time. Our width is equal to width, and so that was going to be a 5 meters. And our height was equal to 5 minus 2, which is 3 meters. Okay, so 5 times 8 is 40, times 3 is 120. So that all multiplied together seems to fit. And so that would be our solution then to this problem. All right, so again, we have a right circular cylinder. So we know, how that looks. Okay, and so what does it tell us? The radius and height differ by 1 meter. the radius is larger. All right. Well, if that's the case, then let's say h is equal to the height, and our radius is going to be height plus 1. Okay. And so that gives us both of these in terms of h. And what was our volume of that? That was pi r squared h. And so now we can say, well, volume is 48 pi equals pi times h plus 1 squared times h. Now we have to square that, so that's h squared plus 2h plus 1. And then we have to multiply that by h, and so we get 48 pi equals pi times, and then we have h cubed plus 2h squared, and then we have plus h. Okay. Now our pi's cancel, and so now we can take our 48 to that side, and well, let's put that over here so we can have maybe some more room. H cubed plus 2h squared plus h minus 48 equals 0. All right, so how many positive zeros? Because that's the key, what we're looking for. Well, no change, no change. We have one change, so one positive 0 is going to be here. Now, negative zeros is going to be negative, and then that's going to be positive, then it's going to be negative, then it's going to be positive. So it's going to be 1, 2, 3. So 3 or 1 negative, but we always have to have positive numbers. So that's really the key. We are only going to worry about those positives. So that's what happens when we come into our P over Q. Our P over Q, well, guess what? Our Q is 1, so we just have to think about the factors of 48. So, and we want the positives. So we're going to have 1, 2, 3, 4 will go in there, 5 won't go in there, 6 will go in there, 7 won't go in there, 8 times 6, so that will go in there. Then 9, no, 10, no, 11, no, 12, yes. And now we're going down, so that means what we took 4 times, and then be 16, and 24, and then 48. So now I think we have them all. And so let's start at the bottom. Let's go 1. And so we have 1, 2, 1, negative 48. 1, 1, 3, 3, 4, 4, no. And so 2. So we have 1, 2, 1, negative 48. 1. That's 2. That's a 4. That's an 8. That's an 8. That's 16. That's a no. All right, so let's try 3. And again, it's just a matter of finding the right one. And there's really hard guesses. Who knows where it is? Maybe it's up here in a 4, 6, 8 region, but we just have to try them all. So that's 3. And that's a 5, that's a 15, that's a 16, that's 48, and that's 0. So that looks to be my value, and it's going to be for h. So it looks like h is equal to 3, and we have meters. And r then is going to be 3 plus 1, or 4 meters. And so that then is my dimensions for the right circular cylinder. Now, does it make sense? Well, r is 4, so 4 squared is 16, times 3 is 48, times pi is 48 pi. So yes, that does work out correctly. All right, so let's stop there, and that would be all I have.